Up to this point, we have been finding the sine, cosine, and tangent of right triangles, but just freestanding right triangles. But what happens if we have an angle that is not an acute angle, an angle that is greater than 90 degrees, an angle maybe that's even greater than 180 degrees? Can we find trig values of those kinds of angles? Probably you're thinking yes, or I wouldn't ask the question. But let's go on the calculator and try these three angles: cosine of 120, tangent of 125, and sine of 330. So on your calculator, if you hover your cursor over the battery symbol, you'll see if your angles is in degrees or in radians. If it's not in degrees right now, if you go to dock, and go to settings and status and go to document settings, you can change your angle from radians to degrees, and then you just push make default and it will say, are you sure you want to do this? And you say okay, and then you are in degrees. That means whenever I use the sine and cosine and tangent and other trig functions on the calculator, it will take my input as degrees. So the first thing I wanted to find, and of course I can't remember what it is now, was cosine of 120. So cosine of 120, you can see that right under the control button is this trig button. You go to cosine and we type in 120, and it says cosine of 120 is negative 1/2. We wanted to find, I'll have to look up what the other two were, tangent of 225 and sine of 330. So tangent of 225 and sine of 330. Okay, so obviously we have values. These all actually have trig values. Notice though that a couple of them are negative. And one is 1, which I guess we've seen that before. So we've seen tangent of 45 as 1. So these are the 120 is clearly not an angle that can be put in a right triangle, and the other two can't even fit in a triangle at all. So where do these values come from, and how do we figure out trig values when we are not in a right triangle? So that's what we're going to talk about today, or we're going to start to lay the foundation. This will be a series of several short videos laying the foundation for how we're going to do this. So the first thing and you might want to write down these, cosine of 120 was negative 1/2, and this was 1, and this was also negative 1/2. Okay. First of all, we are going to define an angle in standard position. First of all, theta is at the origin. We're at the point 0, 0. So we're going to put an angle, kind of a drawing here, and I'm going to draw an angle, and this will be my angle theta. Notice that its vertex is right here at the origin. The initial side of the angle is on the positive x-axis, or at 0 degrees. So this is 0 degrees, or the positive x-axis, and so one side of my angle is on that axis. The other side of the angle, and we call that the initial side, so I will label that. That's the initial side of the angle. And then we measure the angle to the other side, this side right here, and that is called the terminal side. And we call it the terminal side because that is where the angle ends or terminates. So that is the terminal side right there. If we measure the angle counterclockwise, it's measured as a positive angle. If we measure the angle clockwise, it's measured as a negative angle. So we might say if we went this direction, that was a positive 30 degrees. If we went that direction, we would say it's a negative 30 degrees. Now we need to build on that. This is our angle in standard position, and now we are going to talk about a reference angle. The reference angle is the angle between the terminal side of the triangle, it's the terminal side of the angle and the horizontal axis. And you might be more familiar by saying the x-axis. So we're always measuring to the x-axis, and that's very important, never to the y-axis. We're going to create a right triangle by dropping a perpendicular line to the horizontal axis. Once again, never the vertical axis. And use that triangle to find trig values. So in quadrant 1, if I wanted to draw a right triangle, I already have a right triangle here. I could just drop a perpendicular line down like this, and I have a right triangle, and I could label my right triangle, and I'm fine here to use typical ratios of a right triangle in quadrant 1. But if I'm in a different quadrant, what do? So let's say I have an angle in quadrant 2. So let's say maybe this angle right here, we'll say that this is 120 degrees. And I want to find, actually I think I was going to do this, yeah, that's right, cosine of 120 degrees. That's exactly what I was going to do. And I want to find cosine of 120 degrees. Well, to find cosine of 120 degrees, I would need a right triangle, and 120 is not in a right triangle. So I am going to create what's called the reference angle, and the reference angle is the angle between the x-axis, right here, either positive or negative, and the terminal side of the angle. So that is an angle that could be in a right triangle. And that happens to be a 60-degree angle. Why, do you ask? Is that a 60-degree angle? Well, I know this is 180, and I know that's 120, and in between 180 and 20 is 60 degrees. So this has to be 60 degrees. 120 to here, and then another 60 to get to 180. I can drop a perpendicular line, and notice it says I need to drop my perpendicular line down to the x-axis. That's what I set up here, down to the horizontal or the x-axis. And I can create a triangle. Well, if you see a triangle that has a 60-degree angle in it, then I know I've got a 30, 60, 90-degree triangle. There's 30 right there. I can label the sides. 1, square root of 3, and 2. However, there's a catch. Since I am in quadrant 2, the x direction here is negative, so I'm going to call that a negative 1 instead of a positive 1. And notice when I get cosine of 120, I'm doing adjacent over hypotenuse. Adjacent side is negative 1, the hypotenuse is 2, so that's equals negative 1/2. And that's what I got on the calculator when I did cosine of 120, is negative 1/2. It's negative because it's a quadrant 2 angle, and I'm doing cosine, and the adjacent side is negative. The second angle I did was, looking up there, 225. So I'm going to draw an angle 225. That is in quadrant 3, all the way around to here. This is 225 degrees. This is 180. What is the angle in between 180 and 225? Is 45 degrees. Notice I'm looking once again to the angle that's between the x-axis and the terminal side of the angle. 120 and the angle 225 are in standard position. I'm starting at 0 and I'm going all the way around to the angle. Here I'm starting at 0 and I'm going all the way around to 120. So that is considered standard position even though it's not in quadrant 1. So this is all the way around. Obviously I can't draw a triangle with that, any kind of a triangle at all with that angle. But I can make a triangle by dropping a perpendicular line to the x-axis, never the y. This is a 45, 45, 90 triangle now, so I will label my sides 1, 1, square root of 2. However, both the x and the y directions are negative in quadrant 3 now, so when I do tangent of 225, I'm thinking opposite over adjacent. And opposite side is negative 1, and the adjacent side is negative 1, so I get a positive 1 for tangent of 225. So that's what I got on my calculator. The third one was sine of 330. So for sine of 330, now I'm in quadrant 4. I start my angle at 0. I measure all the way around to here. There's my 330 degree angle. So I need to create a reference angle. My reference angle is the angle that's in between the terminal side of 330 and the x-axis. So this is my reference angle, is 30. And sometimes I didn't do this on the other ones, but I could write theta reference is 60 here. Theta reference is 45. Theta reference is 30. Okay, so those are my reference angles. I make a triangle by dropping a perpendicular line to the x-axis again. I have a 30, 60, 90 triangle. My opposite side is 1, opposite the 30. The adjacent side is square root of 3, and the hypotenuse is 2. But now the 1 is negative, and I probably ought to write that so it's a little more visible, because we're in the negative y direction but the positive x direction. So when I do sine of 330, it's opposite over hypotenuse, or negative 1/2. So that is how we use reference angles to find the sine, cosine, and tangent. Hey, it's the, oh good, thank you Mrs. Beasley. That was the intercom there. So that's how we use our special triangles and reference angles to find sine, cosine, and tangent of any angle. And we could go around more than once and find additional angles. But we're going to talk about that a little bit in our next video, which is about coterminal angles.